Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 5, Section 4, using graphs. Not a lot of notes as far as terms today, but we're just going to discuss how to interpret graphs and different types of graphs, so it's really just a discussion. So I have two examples here. This first graph, we're going to graph the growth of a child. When the child is born, let's see, they're going to be more than 12 inches tall. They'll be right about there. And at age 2, I suppose they're right about here. At age 4, you're probably getting close to 3 feet tall. Age 6, kindergarten, you're not 4 feet, but you're more than 3. Or I should say first grade. Okay, age 8, usually about third grade, so let's say you're about 4 feet tall. And then you don't get much taller sometimes by age 10, but then sometime around age 12, 14, people usually grow a little bit, something like this. So now this other graph that we're going to compare to, this graph would be an example of how many people are in my classroom at any one time. So at midnight, at 12 a.m., there is nobody. And at 6 a.m., still nobody. And I get there about 7, so there's one person. And then a few more come in, maybe for help in the morning. And then by 8 a.m., it jumps, and there's, I think there's about 16 people in my first hour. And then they leave, and then second hour comes in, there's a few less people. And then third hour comes in, there's a few more. Fourth hour, there's nobody because that's my planning time, so it's just me, so we're back down to 1. Lunch goes by, still just me. And then after lunch, I have a class of about a dozen. And then I have a very small class. 6th hour. 7th hour is about 12 kids. And then, man, 8th hour, I have a big study hall, so it's off the chart here. And then I'm all alone at 4, and then gone right about 4:30. So I just can't make circles with this pen. That's why I made X's. So let's just compare. First thing I want you to look at for these two types of graph, one of these I should connect the dots because the values do exist in between. But on the other one, I should not connect the dots. It should just be stay just the dots. So maybe you've already figured out that when a child is growing, they're not going from suddenly 1 feet tall one moment, and the very next moment they're 2 feet tall. Of course, they're in between here. So this one should be connected because they are growing very steadily and continuously. So this type of graph is called a continuous graph. It's I like to say you don't pick up your pencil to draw a continuous graph. You connect the dots. But this one, how many people are in my classroom, at no point in time was there 5.5 people in my room. It went from, if I could make all the dots, it went from 5 people to 6 people to 7 people. There is no halves, there's no in-betweens. So this graph should be made up of dots. So the word we have for this is a discrete graph. Now, you don't need to know these words for Algebra 1, but we're going to be studying this in Algebra 2, so I'm just kind of getting you ready for that. So this next part now is going to be interpreting graphs. And part of interpreting graphs is continuing our discussion about independent and dependent variables. So in these two examples, the independent variable is always graphed along the x-axis. So it's not necessarily that you have control over it. That's just one way I explained it. But here, the height of the child depends on at what age they are when we take that measurement. So the age in this example is the independent variable and the height is the dependent. For how many people in my classroom, it depends what time we walk in there and count people. So time here is the independent, it is on the x-axis, and then the number of people is the dependent variable. So we're going to keep talking about that, which one is which. So can you start realizing that the independent variable is always plotted on the x-axis, and the dependent variable is always plotted on the y-axis, and then we'll all have the same scatter plots. Another thing we will be asked to do is describe the general trend. So in this growth of a child, the trend looks pretty easy for me to describe. It's quite plain that the older the child gets, the taller they get. So as one is increasing, the other's increasing. Sometimes these graphs do show a trend. This people in my classroom, the trend would be a little more difficult to describe. We would have to go through it by times. The trend would be nobody at 6 a.m. You just have to kind of make a list if you were describing this graph as a problem in your homework. A lot of people at 8 a.m., not many people at lunchtime, and so on. With interpreting these graphs, often we do not have numbers. We're just looking at the trend and interpreting that. So if this graph, this first one, is supposed to be, I'm going to pick on Hunter here, the speed that Hunter is running versus his heart rate. So here's Hunter at resting speed, resting heart rate, waiting for the race to start, and then it starts. And then as you start running, your heart rate increases, and then you really pour it on, and you're just giving all you got. Your heart rate's going up, 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 and then the race comes to a stop, and so your heart rate starts slowing down, slowing down, slowing down, slowing down. You're cooling off, and then it gets back to its resting. Again, just a trend. There's no numbers here. Another example of that, if I was going to graph the speed as a person is driving to work. So you're sitting in the driveway, your speed is 0. You start here on the graph. Then you pull away from the curb and you start accelerating, and you get onto whatever road you're going, and your speed levels out because you're going, if you're on the highway, maybe you're going 55, maybe you're at a city road, you're going 30. Oh, then you come to a stop sign, so you slow down and stop for a minute, sit there, and then you accelerate back up again to whatever the speed limit is and drive. And then you pull into Hart Ranch, you slow down, and then you're going slowly through the driveway of Hart Ranch, and then you pull into the parking lot and you're going slowly to get into your parking spot, and then you stop. Again, there's no numbers here. It's just a graph showing the trend. Okay, couple more trend graphs to look at. If we were asked to graph the speed of a skydiver, so you're ready to jump out of the plane. You're at the cruising height of the plane. I'm not counting that speed. I'm counting the falling speed. So the skydiver jumps out, starts falling, rapidly begins accelerating. The speed is going faster and faster as you're dropping. And then you reach a point where you have, they call it terminal velocity. You're not going to speed up anymore, but you're falling at the rate of gravity. And you're just free falling, enjoying the sights. And at some certain altitude, you are required to pull your chute so that you have enough time to slow down. And then when you deploy your chute, your speed drops drastically. You slow way, way, way down until you reach the speed that the parachute's going to bring you, and then your speed kind of levels off again, and then you're coming closer to the earth, and then you land. Okay, so again, it's a graph showing a trend. Okay, in this next example, let's just do the trend of, let's say you're sitting outside and you're counting people as they enter Rapid City Christian. So if you're sitting there at 6 in the morning, and I'm trying to think, Ms. Prawl would be here and maybe Mr. Mark, the janitor. So we just have a few people. So we're just doing a trend now. So not many people in the building at first. And then, well, we get to be about 7:30, some people are arriving, and then it sharply increases between 7:30 and 8, and lots of people come in, and then it sort of levels off. And then maybe we have some people leave for an appointment, some people come in, so it's not going to be perfectly flat. There's going to be fluctuations. Afternoon comes and goes. When it hits 3 o'clock, it goes way down. A lot of people leave, but it doesn't get to zero because many people are staying for sports or Knowledge Bowl or what have you. And then 5, 6 o'clock rolls around. We're getting pretty low, people going home. On this particular assignment, on page starts on 203, we did 1 to 12 without a calculator, and then we learned some calculator skills for the rest of this assignment. So you're going to have to talk to me or somebody in your classroom. We're going to learn how to enter things on the lists and do regression lines. So that's something that's easier explained in person. So I think that's pretty much the knowledge you need to do section 5.4. So have fun with math.